Please welcome on your screens now Paul Special, the Chief Product Officer at Scality, also our gold sponsors for SODACON 2021. He will be speaking on multi-cloud data management in practical usage. Over to you, Paul.
Hello, and thank you very much. It's a pleasure to be back here at SODACON. It's been a number of months since we last presented. Yes, I want to talk about multi-cloud data management, what we're seeing in practical real-world usage. As a means of introduction, let me provide a little bit of context. Since we've now been in the market for multi-cloud data management for about 4 years. We originally introduced the product that you might know us for called Zenko as an open source project going back to 2017. That was the time that we started hearing from our customers that they had problems emerging to manage on-prem data with public clouds, things like Amazon, Azure, Google, and others. We introduced Zenko to provide a solution for that. Think of it basically as providing a multi-cloud namespace. It's an S3, an Amazon S3 API compatible namespace that on top provides data mobility policies and allows you to manage your data between on-prem and cloud data storage. So now we've been in the market for all these years. What have we heard? That's the next thing we really want to talk about. So let me start by saying that we've heard a very wide range of requirements. People have a lot of ideas about how to use cloud data management. Some of them use multiple clouds. Some of them have on-prem systems. Really a set of 3 sort of key use cases have emerged. You see them listed here, and I want to describe them in a little bit more detail. So those are cloud archiving, cloud data bursting, and what we're referring to as cloud disaster recovery. On top of that, we are starting to see commercial usage. So people setting up cloud services for things like data ops, big data analytics, cloud and analytics services, and also commercial data storage solutions. So let me talk about each of these quickly in turn. So let me talk about the customer first. So one of the obvious ones that we heard over the last 4 years is, I have a lot of on-prem data. It ages over time. It gets dormant. It gets colder. People need a solution for tiering that data off to something that's more cost effective, something they can use for long-term cold storage. And of course, this is where the cloud excels. They have things like Azure Cold Storage, Amazon Glacier. The solution that we provide are lifecycle policies to help move data based on an age rule or a date rule. So that one is very common and very popular. The second one I mentioned is something we're referring to as compute bursting, or data bursting to compute is more accurate. This is where people have data that's active on-prem. It's something that's valuable. They want to process against it. However, the processing or compute service lives in the cloud. This could be an AI or ML service, something like Amazon EMR in the analytics space. In media and entertainment, there's transcoding, content delivery. Here, what we need is the ability to replicate or move some data based on tags or filters or something that we can identify within a bucket and move that to the processing service. So that is use case number 2. The third one that I talked about is disaster recovery, but you could think of this as business continuance. Now the need is to maintain 2 copies. This might be a copy on-prem and a copy in the cloud, but the idea is that if there's a failure of the primary, we have a low recovery point objective, low RPO copy that is available for use in the cloud. So let me talk a little bit more about how we see customers using this. So this is an example of the cloud DR use case. This example comes from life sciences. So this is a real world biopharma company based in the US. What do they have? They have lots and lots of genomics data. They need to process that on-prem. The compute and storage solution requires a high performance file system, a flash file system. They have this on-prem. That is where the engineers, the researchers access the data, but they're storing this 10 petabytes of data in an on-prem object store solution. So where does multi-cloud come in? Multi-cloud comes in for the DR copy. They're actually using Zenko in Amazon to be able to replicate the data from the object store on-prem into a cloud bucket, into S3 buckets, and also to manage the failback to the on-prem environment in the event that it had an outage and needs to be restored. So the value proposition here for the customer is very compelling. This customer actually had a second physical data center, East Coast and West Coast US, but they saw it as a time to market advantage and a CapEx advantage to go with the public cloud. So that is example number one. Let me talk about another one that is closer to the multi-cloud data bursting that I talked about. This one we can name publicly. This is Bloomberg, the well-known media network. They are global. What is their problem? Obviously, they have lots and lots of video asset data that they capture daily for their broadcasts. They viewed the cloud as a way to drive content distribution globally. So what they were really looking for was a content lifecycle management capability across many clouds. What they realized is that especially for media data, cloud egress is very costly. Exiting data from these public clouds. So what they thought is, let's store content on multiple cloud providers, each one for a different region or endpoint, and that would also provide a higher degree of uptime across all of these clouds. So the solution we provided was essentially an on-prem object store plus Zenko. And what Zenko is providing is a replication from on-prem to multiple cloud targets simultaneously. In fact, they transfer to over 10 or 12 cloud endpoints based on the different geographic regions. And they do this for two reasons. One is to provide transcoding services in the cloud. It's a very bursty, on-demand type of requirement. And then they use the cloud endpoints, the CDN endpoints, to actually deliver content to the end user. By doing this, they also eliminate the egress charges from putting everything into one cloud and then later deciding to read it out. So very cost effective. I mentioned that there is growing commercial usage of Zenko as well. We've seen it now in multi-cloud data services. You can take a look at Saji's data orchestrator. Think of it as ETL type services and visualization of data workflows. And this is something that can work across clouds. Last year, Fujifilm announced an object archive, which is an S3 object to tape solution. They have actually extended Zenko now with Amazon Glacier API. So another benefit of us being in the open source is to receive these kind of contributions. And then finally, our own storage systems also embed Zenko technology. This is something that we can use for multi-cloud data management for the use cases that we just talked about. So I wanted to kind of conclude and say, this is real, it's happening, it is converging around a set of very popular use cases. We are starting to see new requirements now emerging for more advanced data management policies. These are user-defined, where the user gets to introduce their own rules, their own triggers, their own functions, perhaps for invoking the cloud data management function. I'll talk about that later this afternoon. We have another 10-minute talk at 4:05 p.m. Pacific time. So with that, that concludes my presentation. Thank you very much.
Thank you so much, Paul, for that quick talk. Unfortunately, we are over time, so we will be taking up the questions offline. Thanks again for spending time with us here at SODACON 2021, and also thank you for joining us as our gold sponsors. With that, now we will move to the next session, and that is going to be challenges and opportunities for storage in cloud native world. That is going to be by Rakesh Jain. Please join the session with me. We will be going out of the session now.